Okay, in our last section about vectors, we're going to learn about a operation on vectors called a dot product. There really isn't such a thing as called multiplying vectors. There's adding, there's subtracting. Multiplying and dividing really don't exist. But there are a couple different kind of multiplication. One is called a dot product, which we'll cover in this section. Another one that'll be covered in future coursework is what's called a cross product. But a dot product really is just a single number that is calculated between two vectors. And then we'll see some applications that can be done with this dot product here in a little bit. Now it's really easy to find. So if we're given two vectors, let's say we're given vector A1, B1, and vector A2, B2. So we have an A and a B for the first vector and an A and a B for the second vector. Then the dot product, the single number, is given, we usually write it as A dot B, and it is simply A1 times A2 plus B1 times B2. So all we're really going to do is multiply the x components, multiply the y components, and add those together. So if we look at these two vectors as an example, so if we have vector A, which is negative 4i plus 6j, or if we want to write it in our other notation, recall that's just simply negative 4 and 6. And then B is 7i plus 8j, and that's simply 7 and 8. If I want to find the dot product, A dot B, then that's simply negative 4 times 7 plus 6 times 8. So that's negative 28 plus 48, so that is 20. If I do B dot A, so if we start with the first one instead of the second one, that will be 7 times negative 4 plus 8 times 6, but that's also going to give me 20. So this is one property of a dot product. We know it as commutative. That A dot B is the same as B dot A. You can also do a dot product with itself. So a dot product with itself might look like this. A dot A would be negative 4 times negative 4 plus 6 times 6. So negative 4 times negative 4 is, of course, 16 plus 36. So that has a dot product of 52. This last thing is really review from the previous sections. When we do the double bars, remember the double bars mean magnitude, mean how long. And the magnitude is just equal to the square root of the two components. Or the magnitude squared is equal to the x component, so in this case negative 4 squared plus 6 squared. We'll use this in our application we see today. So the magnitude squared is going to equal 16 plus 36. So the magnitude of a squared is going to equal 52. So when I take the square root, the magnitude of a is equal to the square root of 52. So dot product gives you a single number, as does magnitude. Magnitude is how long it is, and the dot product is between two vectors, and it's just a special number. So the big thing we're going to use dot product for is to find the angle between two vectors. So if I have two vectors in the plane, let's just kind of sketch two vectors somewhere. So here's my first vector, and let's say we have another vector going this way. Then there is an angle between these two vectors, and that's the angle we're going to try to find. So it has a really nice formula. It says if vectors u and v are two non-zero vectors, then the angle theta between 0 and pi, or 0 and 180, between u and v is determined by the formula the cosine of theta equals u dot v, so there's my dot product on top, times the magnitude of u times the magnitude of v. So we're doing the dot product between the two vectors, and then in the denominator we're multiplying both vectors' magnitudes. And that will equal the cosine of the angle. And then, of course, if you have the cosine of the angle, you can find the angle. So let's do an example. These are the same two vectors from the previous page. So we have negative 4, 6. So I'm just going to kind of sketch them. So there is vector A. And vector B is 7, 8. So 7, 8 is up here. There's vector B. So the angle we're trying to find, the angle we're going to try to find is between these two is right here. This is the angle we're going to find. So if we use the formula, it says the cosine of this angle between the vectors is first equal to the dot product. Now we did this dot product on the other page, but we can do it again. It's negative 4 times 7 plus 6 times 8. And on the bottom, we're going to do the magnitudes of each vector. So for A, it's the square root of negative 4 squared plus 6 squared. This is the one we did on the previous page. And for vector B, it's going to be the square root of 7 squared plus 8 squared. So the cosine of theta is going to equal 20, because that's our dot product. And then 4 squared plus 6 squared, we said was 52, so square root of 52. And then 7 squared, which is 49, plus 8 squared, which is 64, is 113. Now, because I have two radicals on the bottom, I can multiply those. So the cosine of theta will equal 20 over the square root of 5876. So, but that's just our cosine. What we want is the angle. So to find the angle when you're given the cosine is we will take the inverse cosine. So the inverse cosine of 2 over the square root of 5876. So if I put that in my graphing calculator, this is 20, I don't know why I lost the 0. Graphing calculator, Desmos, whatever you put it in, it's going to give me 74.9. And if I looked at that angle, I would believe that to be a 74.9 degree angle. A right angle would almost be like this. So a little shorter than that, so I would believe 74.9 as my angle. So this formula is pretty easy to use. You just have to find two magnitudes of the dot product, take the inverse cosine, and you will get your angle. So we have a couple special kind of vectors we're going to look at. One is called parallel vectors. Parallel vectors are going to be any two vectors in the same direction. So two vectors in the same direction. So if I have my plane here, if I have one vector going this way, maybe my second vector is going this way. So if they're going the same way, we call them parallel. Orthogonal vectors are going to be two vectors that meet at a 90, so with a 90-degree angle in between them. A neat thing about them for orthogonal vectors, anytime their dot product is equal to 0, they're automatically orthogonal. So we have one vector maybe this way and another vector maybe this way. So those would be orthogonal. So if we want to look at some examples, whether the following vectors are parallel, orthogonal, or neither, so we can just use the formula to find the angle in between them, see if it's 90, or see if it's 0, or see if it's 180, or see if it's some other angle. So if I look at this first one, the angle between them, remember it's the cosine of the dot product, so negative 1 times 2 plus negative 6 times negative 1 all over the individual magnitudes, which is the square root of negative 1 squared plus negative 6 squared times the square root of 2 squared plus negative 1 squared. So the dot product on top is going to give me 4, because it's negative 2 plus 6. And on the bottom, the first one is going to give me radical 37, and the second one is going to give me just simply radical 5. So the cosine of theta is going to equal 4 over radical 185, because 37 times 5 is 185. So theta is going to equal the inverse cosine of 4 over radical 185. And if I put that in the calculator, I'm getting 72.9. So to answer this question, are these parallel? Do they go the same direction? No. Are they orthogonal? No, because they don't meet at a 90. So this would just be simply neither. Okay, let's look at vectors A and B and see what we can figure out about those. And there's a graph on the bottom if you wanted to graph them. I'm not graphing them, but you certainly could. So if I find the angle between these two, it's the cosine of 7 times negative 2 plus 2 times 7 all over the magnitude of A, which is 7 squared plus 2 squared, times the magnitude of B, which is the square root of negative 2 squared plus 7 squared. So that's going to give me negative 14 plus 14 on top, which is 0, over, we have two of the same thing. It's 49 plus 4, which is 53, and this is the same one. But if you notice, 0 over anything is 0. So this is essentially saying the cosine of theta equals 0. So if I take the inverse cosine of that, the inverse cosine of 0 is going to give me 90. So right away, because their dot product is 0, because the angle between them is 90, they are orthogonal. All right, let's look at one more. We have 8, 2, and 4, 1. So if I find the angle between these, so we'll say the cosine of theta equals 8 times 4 plus 2 times 1 all over the magnitude of the first, which is 8 squared plus 2 squared, times the magnitude of the second, which is 4 squared plus 1 squared. So the cosine of theta on top is going to be 32 plus 2, which is 34. And on the bottom, this is going to be square root of 68 times square root of 17. And so this is going to give you the cosine of theta equals 34 over the square root of 1156. And ironically, the cosine or the square root of 1156 is 34. So we get 34 over 34, which is 1. Now, if I take the inverse cosine of 1 to get my angle theta, I'll get an angle of 0 degrees. So the angle between them is 0, so they are parallel. And if I were to graph this one, just to kind of show you, so we have 8, 2, so we have a vector that goes this way, and 4, 1, a vector that goes this way, you can see that they're pointed the same direction, so thus they're parallel. So finding the angles between them is just kind of using this one formula, just kind of a neat application of the dot product.